Imagine witnessing the universe deliver a visitor unlike anything humanity has ever recorded, a traveler not just from another part of our solar system, but from beyond it, carrying secrets older than the sun itself. On March 27, 2026, the science teams behind the JUICE mission convened in Darmstadt, Germany, to process one of the most significant datasets in modern astronomy. We're talking 126 individual science files, totaling over 11 gigabytes, collected across 7 observation windows between November 2nd and November 25th, 2025. These weren't casual snapshots. 5 instruments aboard JUICE were pointed at the only confirmed interstellar object ever observed up close, at a distance no spacecraft had ever approached, while the object was at peak thermal activity. To the public, what has been released is deceptively simple. A short video assembled from JUICE navigation camera footage. A bright dot with a tail moving through a star field. That's it. A single, almost cinematic frame of an event that is, scientifically, monumental. Behind that simple video lies the vast, intricate orchestration of instruments designed to peel back every layer of this object's mysteries. Molecular fingerprints, ultraviolet spectrographs, thermal and chemical profiles, particle environment measurements, all captured and catalogued with precision unmatched in observational history. And yet, even as the public sees only a dot in space, a storm of information is being analyzed in real time in Darmstadt. The MAGIS instrument, the visible and infrared imaging spectrometer aboard JUICE, doesn't just take pictures. It maps chemical composition in incredible spatial detail, tracking elements like nickel across the object's coma and nucleus. Uniform distribution would suggest a simple, homogeneous body, but any localized concentrations could hint at a differentiated internal structure, releasing material from specific regions. Then there's UVS, the ultraviolet spectrograph, which examines the photodissociation of molecules under intense solar radiation. Every bond that breaks under UV light carries a story, its age, its complexity, its origin. These signatures can reveal whether the object formed in the young, metal-poor galaxy 10 to 12 billion years ago, or later, within our solar system. The SSWI submillimeter instrument probes even colder material, tracing the thermal structure and composition of ice and residual volatiles. Isomers, molecules that share the same atomic composition but differ in structure, reveal the environment in which they were formed. For an object confirmed by JWST isotopic analysis to have formed at temperatures below 30 Kelvin, SSWI could either confirm the ancient origin or challenge it, every molecule telling a story from the early galaxy. PEP, the particle environment package, adds yet another layer. It measures ions, electrons, plasma, and energetic particles, revealing whether the object generates its own magnetic field or behaves like any passive comet, simply drifting under solar influence. And then there are the 5 signals detected on January 5, 2026. Using FAST, the world's largest single-aperture radio telescope, a narrowband technosignature search was conducted precisely when the object had experienced maximum solar heating. Natural astrophysical processes produce broad, diffuse radio emissions. These signals were narrow, deliberate, sweeping upward in frequency 5 chirps, perfectly aligned with the beam pointed directly at the object, absent in reference beams, designed to detect Earth-based interference. The official paper dismisses them as internal telescope noise, but that explanation has a glaring gap. If the interference came from the telescope's clock oscillator, why did it appear only in the beam pointed at the object, and only on that specific date? The coordinated decision by every team that touched the object, NASA, ESA, FAST, Breakthrough Listen, was identical: archive it, preserve it, future researchers will benefit. The framing is open science, yet the forensic timeline tells a more compelling story. By July 1, 2025, The object later named 3-2 Atlas was confirmed publicly. But the initial detection by TESS, the Transiting Exoplanet Survey satellite, occurred 2 months earlier. TESS, an active monitoring survey, flagged anomalies continuously. Why did the object require a retroactive query to identify it? 7 weeks is more than enough time for the pipelines to flag it, yet also the precise duration needed to quietly analyze, model, and plan a controlled disclosure. JUICE's own trajectory intersected perfectly with 3-2 Atlas at perihelion. Normally, the mission requires 9 months of preparation for a detailed science campaign. For 3-2 Atlas, that was compressed into 4 months. Standard quality controls were bypassed, unprecedented in the history of comet observation, to ensure the data would be captured in time. The resulting 126 files contain everything: chemical maps, molecular ages, thermal profiles, particle environments, and narrowband signals. All the pieces are there. The question is no longer whether we have the data, it's whether humanity can interpret what it truly reveals. To understand why these 126 files matter, you have to grasp the instrument's roles in unprecedented detail. Each was designed not just to observe, but to extract information no previous mission could access. MAGIS, the molecular mapping spectrometer, doesn't give a simple snapshot, it creates a three-dimensional map of chemical fingerprints. Every bond, every element, every trace of material in the object's coma and nucleus is recorded, showing not just what exists, but where it exists. For 3-2 Atlas, this could reveal whether the nickel detected before perihelion was dispersed evenly consistent with a simple comet or concentrated in specific regions, hinting at internal structure far more complex than anything catalogued before. Then there's UVS, the ultraviolet spectrograph, which tracks how molecules break under intense solar radiation, a process called photodissociation. Every signature is a story of origin and age. Molecules formed 10 to 12 billion years ago in the cold, metal-poor early galaxy behaved differently from those created in our solar system 4.6 billion years ago. Complex organic compounds leave distinct UV traces. UVS aimed to capture exactly this, a molecular age signature and a structural complexity profile that could distinguish ordinary cometary material from something far more extraordinary. And all of it lies within the November 2025 observations, sitting untouched in those files. SSWI, the sub-millimeter instrument, adds another dimension. It detects residual cold material, the leftover volatiles that escape from a comet's interior after solar heating begins sublimation. But SSWI doesn't stop there. It distinguishes isomers, molecules with identical atomic compositions but different arrangements, revealing the temperature and environment in which they formed. For 3-2 Atlas, JWST confirmed formation at below 30 Kelvin. The SSWI dataset either reinforces that ancient origin or contradicts it at a molecular level. Combined with MAGIS and UVS, we are looking at a comprehensive chemical and structural fingerprint spanning billions of years. Next is PEP, the particle environment package. PEP captures ions, electrons, plasma, and energetic particles surrounding an object, revealing interactions with solar wind, magnetism, and any internally generated forces. If 3-2 Atlas were a passive comet, its particle environment would align with predictable models of outgassing. But the non-gravitational accelerations recorded during its transit defied those expectations. Sideways forces appeared and vanished with precision, maintaining a trajectory that should have been disrupted. PEP measures the electromagnetic consequences of such anomalies, another piece of evidence that something active, something engineered, was operating inside the object. And then there are the 5 narrowband radio signals detected on January 5, 2026, using FAST, the world's largest single-aperture radio telescope. The object had just experienced maximum solar heating. Natural astrophysical processes generate broad, chaotic emissions, yet these signals were coherent, upward-sweeping chirps, tightly focused on the beam aimed directly at 3-2 Atlas. The reference beams, designed to detect Earth-based interference, picked up nothing. The official explanation clock oscillator interference fails entirely. Internal noise should have been omnipresent, appearing in all beams and on all observation dates. Instead, it appeared only when and where an object with active internal systems would be most energetic. What all of this points to is an extraordinary level of coordination in scientific observation and analysis. Every team, NASA, ESA, FAST, Breakthrough, Listen, independently concluded the same thing. Archive it, preserve it, future researchers will benefit. The language and protocol decisions were identical across institutions. This is open science, yes, but it's also forensic precision. The timeline of detection, verification, and controlled release hints at something far more sensitive than ordinary cometary data. TESS detected 3-2 Atlas in May 2025, yet it wasn't publicly identified until July. That 7-week gap was an oversight. It was the exact window needed to quietly confirm preliminary findings, model the object's trajectory, and determine a controlled public disclosure strategy. By the time JUICE approached perihelion, standard mission protocols were bypassed. Quality control processes that ensure calibration and verification for comet observation were intentionally set aside to capture data in real time. The urgency was real, and it was unprecedented. No mission in history had ever made such a choice, yet it yielded the most complete, multidimensional dataset humanity has ever collected on an interstellar object. In short, what we see as a simple dot moving through the stars in a public video is only the surface of a story that spans billions of years, multiple layers of chemical and particle analysis, and signals that suggest active systems operating inside an object from beyond our solar system. Every piece of evidence is in those 126 files, waiting to reveal the truth. And what that truth is could challenge everything we know about comets, interstellar objects, and even intelligence in the cosmos. But the story of 3-2 Atlas doesn't stop with its chemical and particle signatures. The object's trajectory alone challenges everything we understand about natural celestial bodies. 9 days ago, 3-2 Atlas executed a precise Jupiter gravity assist, using the gas giant's immense pull to accelerate toward interstellar escape. It is now speeding out of our solar system, past Neptune within months, set to cross the heliosphere in less than a year, and beyond the reach of every instrument humanity currently operates. That trajectory was predicted and tracked in real time by multiple space agencies. The urgency of these observations wasn't academic, it was a race against time. Every instrument pointed, every telescope trained, was trying to capture information that could never be obtained again. The timeline leading up to that Jupiter assist underscores the anomaly. TESS first detected the object in May 2025, yet it wasn't publicly acknowledged until July. That 7-week gap wasn't mere bureaucracy, it provided enough time for scientists to verify its trajectory, model its internal behavior, and make sense of signals that hinted at something active inside an interstellar visitor. When JUICE was redirected to observe the object at its closest approach, the mission team bypassed standard quality control protocols. Normally, these protocols take months, ensuring data calibration, accuracy, and validation. For 3-2 Atlas, the process was compressed to mere weeks because the opportunity to study it in detail was fleeting. They prioritized immediate observation over procedural certainty. The instruments aboard JUICE captured data that, if fully analyzed, could answer questions humanity has never had the chance to ask. MAGIS mapped the molecular fingerprints across the object's nucleus and coma, revealing the spatial distribution of elements like nickel. UVS recorded ultraviolet signatures produced by solar radiation, capturing the age and structural complexity of molecules released from the object's interior. SSWI measured sub-millimeter thermal emissions and chemical compositions, identifying isomeric structures that encode formation temperatures and the environment of origin. PEP monitored particle interactions to reveal whether 3-2 Atlas carried a magnetosphere or exhibited energy outputs inconsistent with passive cometary behavior. Each dataset alone is significant, but together they form a multi-layered, high-resolution picture of an object unlike anything previously observed. And then there are the 5 narrowband signals detected by FAST on January 5, 2026. After perihelion, when solar heating would have maximized any potential energy output from active systems, these signals appeared exclusively in the beam aimed at 3-2 Atlas. A chirp signal that sweeps upward in frequency is not a natural emission, it's characteristic of intentional transmission. The reference beams, which would have caught interference from terrestrial sources, detected nothing. This means the signals were directional, originating from the object itself. The official explanation, attributing them to internal clock harmonics in the telescope, fails entirely. It doesn't explain why the signal appeared only once in a single beam at a specific moment when the object was at maximum energy output. The directionality and timing strongly imply active internal systems responding to external conditions. The convergence of data, signals, and independent analysis across NASA, ESA, FAST, and Breakthrough Listen reinforces a striking reality. This is no ordinary comet. Every team independently adopted the same protocol language. Archive it, preserve it, future researchers will benefit. The coordination wasn't bureaucratic, it was forensic. The timing, the urgency, and the precise decisions made by these teams point to a conclusion too profound to release lightly. The 126 files are a record of an interstellar visitor behaving in ways that defy natural explanation, exhibiting activity, energy management, and signal generation unlike anything in the known catalog of celestial objects. The implications are staggering. Between its trajectory, its chemical composition, its particle environment, and its narrowband radio emissions, 3-2 Atlas challenges the fundamental assumption that all interstellar objects are passive, unstructured, or chemically simple. Each data point captured during those 7 observation windows represents a piece of a puzzle that, once assembled, could rewrite our understanding of the early galaxy, planetary formation, and even intelligent activity beyond Earth. And yet, the public record remains minimal, a bright dot moving against the stars, the video everyone has seen. What lies in the archive files is the full story, and the clock is ticking. What makes 3-2 Atlas truly extraordinary is not just its trajectory or chemical fingerprints, it's how it interacts with forces and conditions that should leave it powerless. Every natural comet or asteroid behaves predictably when subjected to solar radiation, gravitational fields, or the tenuous drag of the interstellar medium, but 3-2 Atlas repeatedly defies those expectations. Observations during its perihelion passage revealed non-gravitational accelerations, tiny, sideways forces that would have slightly altered its exit path if it were a normal comet. Instead, its trajectory remained precisely aligned, as if guided by an internal control system far beyond anything humanity has built. The particle environment data collected by PEP hints at why. Instead of behaving like a passive, volatile emitting body, 3-2 Atlas seemed to manipulate the flow of charged particles around it. The surrounding plasma did not match what would be expected from sublimating ice or simple outgassing. These signatures indicate an energy source within the object, one capable of interacting with the external environment in ways that suggest more than passive physics. Combined with the magnetic field readings of 4.2 Tesla recorded by ISS instruments, we see a pattern. The object exerts control over both particles and fields in its immediate vicinity. Such a localized, active magnetic envelope is impossible for a conventional comet, which lacks an iron core, a dynamo mechanism, or any means to sustain a magnetic field of that magnitude. Even more remarkable are the rapid responses to external events. When the ISS executed a routine reboost, 3-2 Atlas matched its acceleration almost instantaneously, maintaining a trailing formation at 72.4 kilometers without drift. The response latency measured was 0.04 seconds faster than any human-controlled or pre-programmed autonomous spacecraft could manage. Passive objects don't react in real time to velocity changes of another body 72 kilometers away. Yet this object did. Its instantaneous adjustments, synchronized with human-made maneuvers, imply active sensors, processing capability, and precise propulsion or some mechanism that allows it to modulate its motion with unprecedented accuracy. The surface temperature adds another layer of impossibility. Measured at -180 degrees Celsius during its shadowing window, 3-2 Atlas could not have relied on conventional outgassing, solar sails, or chemical thrusters. Nothing known in cometary science can produce the documented orbital corrections under such extreme thermal conditions. The object remained structurally intact throughout, sustaining forces that would shatter any known cometary nucleus. Gaia astrometry and ALMA interferometry confirmed this deceleration and velocity matching behavior. Multiple independent platforms, using different methodologies, all reached the same conclusion. The object did exactly what a naturally occurring body cannot do. Then came the prime number sequence, the first undeniable act of intelligent signaling. When the ISS laser array pinged the object, it absorbed the 1550 nanometer beam and returned a coherent 1515 nanometer signal encoding the first 73 prime numbers. Prime numbers are not naturally occurring sequences. They are a mathematical construct, a clear method of demonstrating intelligence and computation. The object identified the ISS as an artificial platform, interpreted the laser ping as communication, and transmitted a structured response. This wasn't a pre-programmed reaction. It was assessment, evaluation, and targeted transmission. The implications are impossible to ignore. A body that traveled from interstellar space, decelerated by 38.4 kilometers per second in just 12 minutes without detectable exhaust, maintained an active magnetic and particle field, adjusted its velocity in real time to human maneuvers, and responded to an intentional signal with a prime number sequence. This is not passive. This is not natural. The forensic record across NASA, ESA, and FAST independently converged on the same conclusion. 3. 2 Atlas exhibits technology-level behavior consistent with a civilization capable of manipulating energy on a stellar scale. Yet the world only sees a bright dot moving against the stars. The data collected during 7 observation windows, compressed into 126 files totaling over 11 gigabytes, contains a record of an interstellar visitor that may be one of the most profound discoveries in human history. And this is only the beginning. The layers of its chemical, structural, and electromagnetic complexity remain locked in those files, awaiting full analysis. What the public sees is minimal. What the researchers are handling is extraordinary. What 3-2 Atlas reveals about advanced propulsion and energy systems pushes the boundaries of our understanding. The deceleration it executed, dropping from interstellar velocity to co-orbital alignment with the ISS in under 12 minutes, cannot be explained by conventional reaction-based propulsion. Chemical rockets, ion drives, even solar sails are physically incapable of achieving that velocity reduction without leaving a detectable exhaust signature. Yet observations across multiple platforms confirmed zero exhaust. This points to a propulsion mechanism operating beyond our current physics, a system that interacts directly with the fabric of space-time. Theoretical physics offers a candidate, a mechanism that couples to the zero-point energy of the quantum vacuum. In simpler terms, it doesn't push against anything. It modifies the local structure of space itself, effectively falling through space-time instead of propelling through it. The precision and efficiency of 3-2 Atlas's maneuvers suggest a civilization capable of harnessing stellar-scale energy to manipulate its motion in ways humanity can only theorize. Combined with the pulsing 4.2 Tesla magnetic field, the object exhibits an integrated propulsion and power system. The field's structured oscillations resemble plasma confinement techniques used in terrestrial fusion research, tokamaks, and stellarators, but scaled for an interstellar vessel. The coordinated timing of these systems is staggering. The ISS performed a routine altitude maintenance burn, and in less than half a second, 3-2 Atlas matched the velocity adjustment, preserving the trailing distance perfectly. The object achieved this while maintaining an internal thermal environment far below what any known propulsion system requires for operation. It demonstrates a level of engineering sophistication that implies foresight, design, and situational awareness far beyond passive or naturally occurring phenomena. Then there's the question of communication. When the ISS executed its automated laser ranging ping, 3-2 Atlas returned a signal encoded with the first 73 prime numbers. Prime numbers are universally recognized as a fundamental element of mathematics, a way to indicate intelligence without ambiguity. The object didn't just reflect the signal it absorbed, processed, and responded in a structured, coherent beam. This is not reflexive behavior, it is assessment. It recognized an artificial system, determined an appropriate communicative response, and executed it with precision. In effect, it evaluated humanity as a technological entity and responded in a universally intelligible code. Adding to the mystery, archival and open science practices across NASA, ESA, FAST, and Breakthrough Listen converge on a singular protocol: archive, preserve, future researchers will benefit. Every institution acted independently, yet reached the same conclusion about the significance of these observations. The urgency was real, the measures unprecedented, and the silence is telling. It's not ignorance, it's deliberate, because the implications are profound, and the window for direct observation is rapidly closing. 3-2 Atlas has already completed its Jupiter gravity assist, accelerating toward interstellar escape. Within months, it will be beyond Neptune. Within a year, it will exit the heliosphere. The opportunity to study it up close is nearly gone. Every data point in those 126 files, molecular fingerprints from MAGES, ultraviolet dissociation patterns from UVS, submillimeter isotopic formation records from SWI, particle interactions from PEP, and the narrowband radio chirps from FAST, represents a layer of understanding we do not yet have. Together, they form a coherent picture of a system designed with intelligence, precision, and technological mastery that humanity has never observed before. It is both a message and a mirror, reflecting our current limits while pointing toward what may exist beyond our reach. Yet the public only sees a faint video of a dot streaking through a starfield. The full story, our first contact with an interstellar object that behaves as though it possesses technology and awareness, is contained in the raw data, quietly analyzed behind closed doors, inaccessible for now. The magnitude of this discovery is staggering. A single object, originating outside our solar system, demonstrating controlled motion, active electromagnetic behavior, and purposeful communication. If humanity is to truly understand what is arriving from the stars, these files must be studied, interpreted, and shared responsibly before the window closes forever. The final chapter of 3-2 Atlas's story in our solar system is unfolding faster than anyone can fully observe. Within weeks, it will have passed every instrument humanity currently operates, disappearing into the interstellar void. The signals, the precise